Hello. Purpose of this video is to look at finding the derivative of a function. Um, Particularly what we're going to do is explore among the shortcuts that we have between the power rule, the product rule, the chain rule, and the quotient rule, which is the best to use under which circumstances. Some students have a tendency to automatically see a fraction bar and say quotient rule, so I'd like to explore that method first. It's certainly not wrong or incorrect to use the quotient rule, but I wanted to show you what it would look like. So to set up the derivative, please recall that the first thing I would do is not actually do any derivatives, just do the setup piece. So we have ho d high, start off with ho, so the bottom function, which I wrote in exponent form, times the derivative of the upper function, minus high d ho, the upper function, times the derivative of the second function, and then over ho ho, which is the square of the bottom function. The derivative of 9x squared plus 3 is going to be 18x, so we get that. And, oops, holy cow. And the derivative of 2 times x to the 1/3, we're going to have 2/3 times, so 1/3 times 2 is 2/3, x to the negative 2/3, so if we take 1/3, subtract 1, we get negative 2/3. And to square the denominator, remember to take 2 times x to the 1/3 times 2 times x to the 1/3, which is 4 times x to the 2/3. Here, 2 times 18 is 36, and x to the 1 times x to the 1/3 should be x to the 4/3. So make sure you remember that when you multiply numbers of the same base, you add the exponents. That's where the 4/3 comes from. And now I'm going to distribute 2/3 x to the negative 2/3 here. So 2/3 times 9 is 6. X squared times x to the negative 2/3. Remember, you add the exponents, and you add 2 plus negative 2/3 is positive 4/3. In other words, 6/3 minus 2/3 is 4/3. 3 times 2/3 is 2, and then x to the negative 2/3. So that takes care of that. Then I'm going to distribute the negative sign, and I recognize both of these are 4/3 power, so I'm going to collect like terms, which is what's going on over here. We have 30x to the 4/3, which used to be 36x to the 4/3 minus 6x to the 4/3. And finally, what I'm going to do is divide by separating these fractions out. And in so doing, notice here I have 30 over 4, which is 7.5. X to the 4/3 over x to the 2/3. Subtract the exponents to get x to the positive 2/3. And here we subtract the exponents to get negative x to the negative 4/3. Now everything I do after that is all cosmetics. If you can get your work up to here, that means you've effectively applied the quotient rule and done some minor simplifications. But I remember I learned this trick that said that if we know the smallest power of x, that will be the common factor. Make this look nicer by factoring out 1/2 x to the negative 4/3, because here 2/3 x to the 2/3 divided by x to the negative 4/3 is x squared. And so we get a much nicer looking result. And here you can see this function looks a lot nicer, and relatively looks a lot more like the original function. So anyway, now that's using the quotient rule, and that's, again, a lot of students, it's not wrong, but this is the first technique they would apply. There are some students who hate the quotient rule, so they always use the product rule. If you wanted to, I won't recommend it. It's the worst method of all to choose from, is to turn a quotient into a product and then use the product rule. But you can do it. Take the entire denominator and express it as the product of the numerator times the denominator to the negative 1 power. So now I can apply the product rule, first times the derivative of the second, plus the second times the derivative of the first. And we have the first times the derivative of the second. Here we have to remember the old chain rule. So that's one of the things that makes this more challenging, is we may not have to use the quotient rule, but we have to use the product and chain rule together. So we're using 2 rules instead of 1. But the derivative of this whole mass, remember, we're going to take down the negative 1, drop the power by 1, and then take the derivative of what's inside. So the derivative of 2x to the 1/3 is going to be 2/3 x to the negative 2/3 from the previous work. Plus, we've got the 2x to the 1/3 to the negative 1, and the derivative, wow, and the derivative of 9x squared plus 3 is 18x. So the rest of this now, that's the derivative. The rest of this is going to be cosmetics. First, notice that this whole first set is binomial times a bunch of stuff. So I'm going to clean up all that bunch of stuff. So we multiply two numbers at the same base. This is x to the negative 2/3 times x to the negative 2/3 is x to the negative 4/3. And negative 2 to the negative 2 times 2/3 is going to give us negative 1/6. I did a lot of step skipping there, but again, that's Algebra 2 stuff. It's kind of a prerequisite for the course. Over here, I'm going to do the same thing, skip a lot of steps just to clean it all up. And the point is, this is exactly the same expression as I had before, which can be simplified or reduced into that form. So, we can see here now, according to my work, it looks a lot less complicated than the quotient rule, but number one, I skipped a whole bunch of steps right in here in the interest of time, and number two, a lot of students who are going to skip an entire rule are also the same students that are going to accidentally forget to apply the chain rule correctly here. So if you apply the chain rule incorrectly, then your shortcut is irrelevant, and you're going to get wrong answers, wrong results. Now, with those two methods out of the way, what's the best way? The best way is actually to recognize this is a monomial in the denominator. We can actually distribute that. That is, divide each separately. In so doing, you get this function for f of x, and in power form, all you have to do is apply the power rule straight up to get this derivative. I showed all the steps. Coefficient times the power, reduce the power by 1. Coefficient times the power, reduce the power by 1. And that all simplifies into this expression, which we've just recently shown gives us the same results as we got before. So clearly, if you do a little bit of work in the beginning, it's going to save you a ton of work later on. So when you look at a function and try to decide which of the shortcuts to apply, you can get the right answer no matter which shortcut you apply. The question is, are you going to finish your test in time? Are you choosing the best possible methods, or are you just choosing the only thing that comes to your head? So it's a great opportunity to demonstrate real learning and real hard work by which method you select when differentiating these functions. So be aware of that as you plow ahead. Hope that's helpful. Have a great day.